This is section 3.05 from Unit 3 Notes, Quadratic and Exponential Regression. Today I am, as in you are the student, learning characteristics of different types of functions so that I can write and use quadratic and exponential regression equations. I will know I have it when I can use technology to find and interpret the equation of a linear, quadratic, and exponential model. Specific TEKS we're looking at for today's lesson is 9F. So there are three models we're going to look at. One of them we've already seen in the previous two lessons. The linear equation is a straight line from left to right, either in a negative orientation or a positive orientation. Again, we've already dealt with this in sections 3.03 and 3.04, finding the linear regression, the line of best fit. We're going to add two more equations to our repertoire of models that we can use for scatter plots. Quadratic, which is a U-shaped graph. Either it's shaped like a U or shaped like an N. U being the positive orientation and then the N being the negative orientation. So quadratic. And we're going to add the exponential line of best fit, exponential equation, which is a curved then almost flat line. So there's probably about 4 different orientations for this. Depends on what we are dealing with. But in general, either it'll start at a curve and then flatten, or it'll start at a flat and then curve. Okay? And again, there's about 4 different orientations. We'll go through them as they come, but yeah, exponential. So, like I said, we are dealing with scatter plots in this unit. Scatter plot being a graph with a whole bunch of dots, which represents 2 different sets of data graphed to see if there's some sort of relationship, some sort of pattern that we can get from it. Linear regression is what we dealt with the previous 2 sections. So linear being a straight line deals with the equation y equals ax plus b. And we use linear regression for scatter plots that have a relatively straight pattern going for it. Now, not every single graph is going to behave linearly. Sometimes you'll have some curvature to it. And so you'll have to understand which one would probably be better in that scenario. So we could have a quadratic relationship going on with the scatter plot. And so maybe instead we would use the quadratic line of regression, quadratic regression line. Quadratic, the equation for that is y equals ax squared plus bx plus c. A, b, and c in general, for all of these, are the numbers that you're going to be filling in to create these equations. The x squared and the x are the ones that stay the same, but you would be filling out these letters, besides the x's, with numbers that we calculate from the calculator. And so something with a U shape would probably best fit the image that we see for this scatter plot. Another one that has some curvature to it is an exponential line of regression, exponential regression line. This one is for something that starts off very nice and easy and then could potentially shoot up very rapidly, or grow or shrink very rapidly. And so maybe quadratic is not the best fit because we notice that quadratic involves U shapes or N shapes. And so maybe instead we want to use an exponential regression line. The exponential regression line equation is y equals a times bx, b to the x power, where again, a and b are numbers you're going to be replacing when you calculate the line of best fit. Okay. Notice the differences. Notice how linear, straight line. Notice quadratic has got a U shape. Notice exponential has a flat, then growth upwards or downwards. Okay, and then notice the equations. Notice how different they are. Notice how linear only has 2 components being added together, ax plus b. Notice quadratic has y equals ax squared plus bx, and then plus c. It's the only one with the c value regarding it, and it's the only one with the square in the formula. Notice the difference with the exponential. It is a times b to the x power. Okay, so these are all the differences between each one of these that it'll help to know when creating the equations, solving the problems in the later examples. So you will need a calculator to find the line of best fit, either through Desmos or the TI-84. In this video, I'm going to be showing y'all both. So whichever ones you have, either the Desmos, which is what I'm going to use in a little bit, or the TI-84, it does not matter. Whichever one you find to best help you, or whichever one you find easy. So we're first going to look at Desmos. Now, if you are using ClassKick for your notes currently, I do have a video of me going over all of it linked right there. So you can either watch this video, or if you have the Desmos, or if you have the ClassKick notes, you can just open up the Desmos video right there and watch that instead. Or I also have a video for the TI-84 as well, linked right there, whichever one. We'll start off with Desmos, though, for this lesson. Okay, so using Desmos, we're first going to create a table. You're going to be given a data set in the form of a table, and we're going to need to input that table into the first line in the Desmos calculator. So you're going to hit the plus sign, click table, and then you're going to enter the values for x1 and y1. Let's scroll down to an example right here. X1 is usually the values on the left, and then Y1 are usually the values on the right. Or if you have a horizontal table, which some problems do deal with, the X values are usually the top part of the table, and then the Y values are usually the bottom part of the table. Okay, so enter the values. And then if it notices a pattern, you can just simply press enter until you get through all of them. And then for the right side, do the same thing. This one does not have a pattern, so it's not going to go as easily. If you want to change stuff about the line or the color, you can click and hold this circle right here that has the color. And then you can change the weighted graphs, you can change the lines, all of it, the colors, etc. The boldness, whatever. I'm just going to change it to purple and be done with it. All right. Now, these are the three different equations we use to find the line of best fit. I'm going to start by the one we've learned from the previous lessons. For linear regression, let me go right here. For linear regression, we're going to go down to line 2 of our calculator, or Desmos calculator, and type the following. Okay, so for linear, we're going to type in y1 squiggly, and if you don't know where the squiggly is, you hold shift and then look at the number 1 key. It should be to the left of number 1. So hold shift and then press the squiggly. And then finish it out. mx1 plus b. I'm going to zoom out so you can see the dots. And then there it is. This will give us the line of best fit, the linear regression line of best fit. Okay. Now, you can use the exact same line, but I'm just going to go to number 3 and then type in for a quadratic, just so I can show you the 3 different types of equations there are. I'm going to turn this one off by just pressing the color of that line right there. And then I'm going to type in the quadratic regression. So you're going to type in y1 squiggly, AX1 squared. And to get the square, either you can pull up the keyboard and use the square right there, the A squared, or you can also, if you look at the number 6, there should be a little up arrow right there on the number 6. You hold shift and then press that. It'll turn it into an exponent. Okay, and then to get out of that, I'm just going to arrow to the right and then finish it out. Plus BX1 and then plus C. And then you can see right here, here's the quadratic line of best fit. And then notice how, regardless of whether there's dots here or not, it's still going to create the equation to fill it out. Whereas the linear just goes straight through it. And again, it depends on what makes sense for in the context of the word problem. Maybe there are values that go up coming over here, and quadratic would best fit a model like this. If not, then maybe linear would make more sense to go just straight through the graph, straight through the points. All right. Now, again, you could X these out and then enter the exponential regression, but I'm just going to go to line 4 and then enter it right here. I'm going to type in Y1 squiggly A, B, and then use the up arrow on the number 6. So again, shift 6 and then X1. Whoops, X1. And then I'm going to click the box for log mode, and there it is. There is the exponential line of best fit. And then just for comparison, the blue is exponential, this red is quadratic, and then the black is linear right there. You can see all the different the differences that it has for each equation. And that's it. That's it for the Desmos calculator, how to calculate all 3 of these. Okay, now if you would better if you like better using the TI-84, I'm now going to show you all the TI-84. First things first, we need to make sure diagnostics is on so we can get other values added to our calculations. So first thing I'm going to do is press second 0 to pick up the catalog button right here, right there. And then either scroll down until you get to diagnostic on, or to better navigate faster, I'm going to look for D, the green D right there, X -1. That's the button I need to press. So I'm going to press X -1. Then I'm in that section that I'm looking for, D. Scroll down to diagnostic on, enter, enter, done. You only have to do this once. So if you've already done this before, you don't have to do it again, period, unless you've reset your calculator. Okay, now we're going to enter our list by pressing Stat Edit. So I'm going to pull this up one more time. I'm going to press Stat and then either 1 for edit, or you just hit enter because the 1 is highlighted. And then I'm going to enter some numbers in there. Now, if there's already numbers there, you can either enter them again and then it'll replace what you have. Or you can go up to L1, highlight it, or L2, hit clear, and then enter. Do not hit delete. That's something completely different. It's going to completely take out L1 or L2 if you use delete. So make sure you hit clear and then enter. If it does accidentally delete L1, L2, you got to reset your calculator. So you're going to press second plus 712. If you reset your calculator, you got to go through and turn on diagnostics again. Okay, so let's go back to edit. Now we're going to enter all our values from the table. So for a vertical table, again, the left side is usually your X's, the right side is usually your Y's. In this case, x's are going to be our L1s, and then y's are going to be our L2s. So just start entering what we need for L1 and L2. L1, we got 1, 2, 3, all the way up to 8. And then go to L2 and then enter all the y values, 25, 31, 34, 36, etc., etc. Okay, and then there we go. Now, what I like to do is I like to get out to the main screen by pressing second mode. You don't have to do that part, but I just prefer to do that just for myself. And then now we're ready to get all the different linear regression equations. So the calculator is going to do all of it for us. We just need to know which one we need to get. So for linear regression, we need to press Stat, go right to Calc, and then for linear regression, we've already done this in the previous sections, we hit option 4, make sure L1 and L2 are right there for the list. If not, you're going to press second Stat, and then you're going to choose one of those lists right there. Okay, but X list needs to be L1, Y list needs to be L2. Go down to Calculate, and then there we have our linear regression equation. Okay, now remember, A and B are what you're replacing. So it calculates A for you and it calculates B for you. So you would use those numbers to then replace A and B and then create your equation. Same thing with everything else that we're fixing to do. So let's say we don't want linear regression. We instead want quadratic regression. So we want to do the following. Click Stat, go to the right to Calc, and then go to option 5 for quadratic regression. Quadrag. Hit Calculate, and then there we go. It'll calculate A, B, and C. And just to show you that we're doing everything like we should, here's the quadratic regression. Here is A, which is 0.196. Here is B, which is 1.92. And then here is C, which is 24.696, etc. Okay, and then the last one, exponential regression, is all the way down at the 0. So we would, if we want to calculate that, we would press Stat, go right to Calc, either scroll down to option 0 or hit number 0. Make sure everything is good, and then it'll create the exponential regression equation there. And then just to show you the comparison, look, A is 24.16, B is 1.10. Okay, now that's how to find the linear regression equations. Okay. So here's an example of how to do quadratic and exponential. I'm going to hide these just for the moment. We're going to go through this together and then have y'all work on the next question by yourselves. Okay? So we're going to start off with Desmos. I'm going to go through this pretty quickly since we've already walked through this before. And we're going to write our equation, or write either the quadratic or the exponential equation based on what the question is asking for. For this example, we're doing both just so we can practice, but the question is going to ask to write for a specific one. The question's on the quiz or test. So first things first in Desmos, we're going to add the table. We're going to enter our values for x and y. Remember, for a horizontal table, x's are at the top, and then the y's are at the bottom. So let's just enter these. And then go to the y values and enter what we have there. All right, once everything is entered, we're then going to do one of the following. Either we start off with quadratic or exponential, it doesn't matter which. For quadratic, we need to type y equals ax squared plus bx plus c. But remember, with Desmos, you need to type it a special way. So you need to type the following. y1 squiggly ax1 squared, the arrow to the right to get back on level, plus bx1, and then plus c. And then here is my equation. Now, we need these numbers to make the equation. So I want y'all to notice A is 0.1485 whatever. We're going to round that to 0.15. B is negative 9.15. And then C is 147.59 if we round that to 2 decimal places. Okay? Then I'm going to do the following. A, let me use a different color. A gets replaced with what we had on the calculator for Desmos right there. Same thing with B and C. I don't know why I did that, but I tried to show them in different ways. And there we go. Don't forget the x values, the x squareds and the x does not change, so that gets brought down. Notice how the b value had a negative, and so that plus changed into a minus. Okay, so be very careful when translating that to your equation. Now, if we want the exponential, we do the following. I'm going to exit out of that, go back to line 2, and then type the following. y1 squiggly a b raised using the up arrow on 6, and then x1. I'm going to make sure log mode is highlighted, and there it is. A should be 323.9. B should be 0.88 about. Don't forget the x value, that is the exponent. And that's that. A and B aren't exactly together, they're separated. So to understand that they're separated, just know that if you don't see it, that means there is multiplication going on in between. Or sometimes you also see a parentheses either around the A or around the B to separate them, and just know to know the distinction where they're applied to. Okay, now if you want to know how to do this with the TI-84, again, I'm going to go through this pretty quickly. Stat, edit. If there are numbers in there, either replace them or highlight L1 and L2, hit clear to get them out of there. Okay, then enter your numbers. For the X's, for L1s, we have 14, 16, 18, and so on. Okay, then arrow to the right to enter your L2s or the Y values. Same thing. Make sure every number has a pair, which it does. Then I'm going to hit second mode just so I can quit out of the screen. To get the quadratic, I'm just going to enter the following. Stat right for calc, and then we don't want linear regression, we want quadratic regression, so we're going to hit option 5. Make sure L1 and L2 are right there, and then hit calculate, and then boom, there we got our numbers. 0.14, which rounds off to 0.15, negative 9.15, which stays the same, but the plus changes into a minus in the equation. And then we have 147.58, which is our C value. X squared and X still stay the same. To get the exponential, we could just go from right here. Stat right option 0 for EXP-reg, for exponential regression. And there it is. 323.91 is our A value. B is 0.88. And that's how we do it with the TI-84. If you're on ClassKick, you can see the steps and you can check yourselves to see how to do that. But that's it for this example. All right. So for you, try number 1, write the quadratic and exponential equations for the data set. You have that table. From that table, either use Desmos or the TI-84, whichever one you want, doesn't matter. And create the equations. If you're on ClassKick, you can move these boxes to check to see if you're doing everything correctly and creating the equation correctly, which is just as important. I got the steps right here underneath Desmos and this picture of a TI-84. So read that and follow along if you get stuck. So go ahead and pause the video, try this on your own and see if you could get the final answer. Otherwise, I'm going to continue on and show y'all how to do this. Okay, I'm going to show y'all both. I'm going to go through this pretty fast, so just understand if you need more detailed explanations, you can just rewind the video and watch me go through the other examples. So for Desmos, we got to create the table and then enter the numbers 1, 3, 3, 5, 4, 8, and 11. Those are the X's. The Y's are 56, 44, 41, 11, 22, 3, and 2. Okay, there's the line, or there's the scatter plot. Now, for exponential, we're going to go to line 2, and then we're going to type the following. Y1 squiggly, A, B, and then up arrow to get the exponent, X1. Click log mode, and then our A will be 99.07, and then B will be 0.68. So again, 99.07, and then parentheses 0.68. And then you can see the little X in the exponent right there. There's our exponential regression line. For quadratic, you're going to type the following. Y1 squiggly AX1 squared, arrow to the right, plus BX1, and then plus C. And there it is. A will be 0.81, B will be negative 0.67, and then C will be 75.41, which you can see right there. Don't forget your negatives. Those negatives do change the sign in the formula to whatever that sign is, which is minus. So be careful when filling that out. But that's it. That's it for Desmos. Now let's look at TI-84. So to fill everything out with the TI-84, you're You're going to press Stat, Edit. You're going to clear these out or replace them. L1 should be the X value. So we have 1, 3, 3, 5, 4, 8, and then 11. L2 should be 56 with the Y values, which should be 56, 44, 41, 11, 22, 3, and 2. Make sure every number has a pair, which it does. So I'm going to press second mode to get to the main screen, and then press the following for exponential. Stat, right, option 0 for exponential. So I'm going to press 0. Calculate, and there it is. Exponential. A is 99.07. B is 0.68. For quadratic, I'm going to type the following. Stat, right, and then option 5 for quadratic. And then there it is. A is 0.81. B is negative 15.67. C is 75.41. And again, notice the sign of the B value changes the sign of the formula to a negative. That's it for both calculators. Here are some problems that involve using set equations, quadratic and or exponential, to predict certain things regarding that data set. So in this, you try. The equation y equals negative 5.131x squared plus 31.821x minus 3.333 approximates the number of people standing in line to catch a commuter train X hours after 5 a.m. What is the best estimate for the number of people in line at 7 a.m.? Okay, so as you can see, I've laid out the steps. Step 1, how many hours is it from 5 a.m. to 7 a.m.? That'll be your X value. And then you'll take the X value and just plug it into the equation, type it into your calculator, and then get your answer. Round it to the nearest whole number, please. So if you would like to try this problem on your own, go ahead and pause the video and go through it, see if you can get the final answer. Move the box behind, or move the black box to see what the answer is, and just check yourself. Otherwise, I'm going to continue on and show y'all how to do this. So from 5 a.m. to 7 a.m., 2 hours have passed. So using that X value, I'm going to plug it in for every one that I see in the equation, all the X values, and then type that all out. Doesn't matter what calculator you use for this. I'm just going to use the TI-84. So I'm going to type in negative 5.131 parentheses 2 squared plus 31.821 parentheses 2 minus 3.333. And my final answer, rounded to the nearest whole number, should be about 40. So the best estimate for the number of people in line at 7 a.m. is about 40 people. Let's just check to make sure. That's our decimal answer, but when rounding it, it should be 40. Should be 40. And that's it for you try number 2. You try number 3. Same thing, except now you're dealing with an exponential equation. Water was drained from a swimming pool. The equation, y equals 14,590 times 0.95x raised to the x power, estimates the number of gallons of water remaining after x hours from the time it started draining. How many gallons of water were in the pool after 14 hours of draining? Okay, so plug the x value into the equation and then solve using the calculator. There's nothing we have to figure out for the x. It's very straightforward. From the time it started draining, that's 0 hours. It has been 14 hours. We want to calculate how many gallons of water were in the pool after 14 hours. Okay, so if you would like to pause this and try this on your own, go ahead and do that. Use the 14 to enter into the equation and enter it into the calculator to get your answer. You can move the box right here if you're on ClassKick to check and see if you did everything correctly. So pause the video, try this on your own. Otherwise, I'm going to go through it and show y'all how to do it. Okay, so we're going to type 14 into our calculator for the x value and then hit enter. Just plug and chug. I'm going to type in 14,590. And then you can hit the multiplication symbol or you can hit the parentheses. It doesn't matter. I'm going to hit multiply. And then just to be safe, I'm going to press parentheses 0.95, close parentheses. Now, depending on what calculator you're using, there could be an exponent button on the Desmos, or you can use that Shift 6 arrow to get it up to the exponent and then type your number. For the TI-84, there is a arrow right here, right above the division symbol. I call it the caret. So that caret you use to get to the exponent and then type in the 14. Hit enter and then it'll calculate. We're going to round to the nearest whole number, which should be 7,115. So 7115. So after about 14 hours of draining, the amount of gallons remaining from this pool is 7,115 gallons. And it started at about 14,590 gallons. And it drained all the way to 7,115 after 14 hours, about. And again, you can move the box to check and make sure. That's just another way you can enter it into the calculator. I like to be safe and use parentheses because when you involve negatives and you don't put parentheses around numbers, it'll give you the wrong calculation. So just to be safe, I add parentheses to certain things. But anyways, that's it for you try number 3. Okay, best fit regression equation. There is another problem that you will encounter where you will be looking for which of those 3 lines best fits the scatter plot that you're using or that you're dealing with. The equation that will be the best fit for the data has the highest coefficient of determination, aka the R squared value. So the R squared value in this example, we've done this calculation before, so I'm not going to go through it, is right here. Okay, so the R squared will tell me which one best fits the table of data or data. So we got R squared for linear, which is 0.878. We got R squared for quadratic, which is 0.9038. And then R squared for exponential, which is 0.896. The one that best fits this is quadratic. Sometimes you're not given the R squared though. Sometimes you're only given the R value. And then from there you have to know how to get the R squared value. Well, simply put, if you're given the R value, let me see if I can zoom in a little bit so you can see some of these numbers better. If you're given the R value, you just square it. So, for example, for linear, I'm going to take the R value right here, type it in. With parentheses, I'm going to put negative 0.9372, close parentheses, and then square it. And I get 0.878, which is right up here. Same thing with quadratic. If you only have the R for the quadratic, which is not shown right here, you would square that. And then with the exponential, if it gave you the r, you would just square it. This one, it does have it, so we're going to go ahead and practice that. I'm going to type in parentheses negative 0.947, close parentheses, and then square it. And then it'll give me the 0.8968 that the Desmos calculator is showing. Okay? And then from there, you just choose which r squared is the highest, and that'll be your answer. So what this means is, in terms of this problem, this example, the regression equation that has the best fit for the data set is quadratic. The quadratic fits the data more so than linear and exponential. Even though linear and exponential have relatively good chances of explaining the data, the quadratic does a better job of it. So we choose that r squared compared to the others. And that's it for this example. Okay, you try number 4. Joel wants to find the best model for a bivariate data set that he is working with. Bivariate basically meaning two different data sets put together to show a relationship. They could be related, they could not be related, doesn't matter. He's just putting two different data sets to create this scatter plot. He used a calculator to create a linear model, a quadratic model, and an exponential model. The coefficient of determination for the linear model was 0.45. For the quadratic, it was 0.52, and for the exponential, it was 0.47. Which model should he use to represent the data set? Hint, the best fit has the highest r squared value. Okay, so coefficient of determination means r squared. Simply find the highest r squared value, and then there you go. There's your answer. So if you would like, you can pause this video, although it's probably not going to be for too long. Pause video, try this problem out, and see if you can get it and get the right answer. Otherwise, I'm going to continue on and show y'all what the answer is. So, simply put, which one is the highest r squared value? Quadratic. Has a 0.52. It's bigger than 0.45 and 0.47. So, quadratic because it is the highest coefficient of determination. That's that. That's it for you try number 4. Okay, that's it for unit section 3.05 notes, and that's it for unit 3 in general. So if y'all have any questions, let me know. You have my phone number and email right there. Text me or call me using my phone number. Anything after 5 p.m. though, I'm a little less inclined to answer, but if it's important and it's an emergency and I see that it's an emergency, I will try to answer as best as I can. Otherwise, just send me a message, send me an email, and I'll try to get back with y'all as soon as possible, okay? That's it for this video. Y'all have a good one. Take it easy, y'all.